Hello everyone, I welcome you all to Gnanataranga program, NEET CET coaching for 2nd PUC students 2018-19, which is organized by Department of Pre-University Education and Government of Karnataka. I am Srinivas Avi. Today I am going to discuss about the last chapters of organic chemistry, that is amines, biomolecules, polymers and chemistry in everyday life. Okay, it's not possible for us to go in detailed synopsis of these chapters. That's why I'm just looking at the content of the chapters given above. First we'll look at the chapter organic compounds containing nitrogen, in particularly amines. Amines are a class of organic compounds which are derivatives of ammonia, in which one or more hydrogens of ammonia has been replaced by alkyl groups. Generally, these amines are nucleophilic in nature due to the presence of lone pair of electrons present in it, which also makes these amines are as a Lewis basis. The nomenclature of amines are like this. The general common name for amines is alkyl amines, and the IUPAC name for amines will be alkanamines. That you will be studying in detail in your classes. And these amines are classified in accordance with the degree of nitrogen substitution. And these are classified as primary, secondary, tertiary and quaternary amines based on the number of alkyl group present on nitrogen atom. In primary amines, nitrogen is just attached to one alkyl group, and in secondary amines, two alkyl groups are attached to nitrogen, and in tertiary amines, three alkyl groups are attached to nitrogen, and in quaternary amines, four alkyl groups are attached to nitrogen. Then we will move on to the physical properties of amines. The solubility and boiling points. The solubility and boiling points of amines, both of these properties depends on the hydrogen bonds present in an amines. More is the number of hydrogen bonds, more is the solubility, and more is the number of hydrogen bonds, the boiling point of amines are also increases. For example, the solubility of lower amines are like this. Lower amines are soluble in water because of the presence of hydrogen bond. Intermolecular hydrogen bond exists between amines and water. And the boiling point, if you come to the boiling points, the primary amines will be having higher boiling point compared to secondary than tertiary. Because of the presence of two hydrogen atoms in primary amine, it will show two hydrogen bond. That's why the boiling point of primary amine will be always higher compared to secondary amine, which has got only one hydrogen. And in tertiary amine, we don't have hydrogen. That's why due to the absence of hydrogen bond, the boiling point of tertiary amines are always less compared to primary and secondary amines. Next, we will move on to the chemical properties of amines. In chemical properties, we will be looking at the preparations of amines by ammonolysis method. Ammonolysis is a method of preparation of primary, secondary, tertiary and quaternary amines by using ammonia and excess of alkyl halide. And the next method is Gabriel thalamide synthesis. It is a method used to prepare a primary aliphatic amines by using thalamide. It's a nucleophilic substitution reaction generally made for the preparation of primary amines. Next, Hoffman's bromide reaction. It is also a preparation of primary aliphatic or aromatic amines by using an alkanamide with bromine and alkali. And also the reduction of nitro compounds can also yield primary amines. In general, while looking at the questions, I will discuss with the concept. Next, basic nature of amines. As I discussed earlier, the basic nature of amines is due to the presence of lone pair of electrons present on it, which makes this as a good Lewis base. And the next important part of amines is a chemical test to distinguish between a primary, secondary and tertiary amines. A reagent like Hinsberg reagent, which is a benzene sulfonyl chloride used to separate as well as distinguish a primary, secondary and tertiary amines. And also we can use nitrous acid, which is also used to differentiate a primary aliphatic amine from primary aromatic amine, as well as the secondary aliphatic and aromatic amines from primary aliphatic and aromatic amines. The last part of amines is the applications of diazonium salts and coupling reactions. in the first chapter itself, we have dealt with a reaction, diazotization reaction, the preparation of diazonium salt by using aniline in the presence of nitrous acid and dilute HCl at 0 degree centigrade. Now we are looking at the applications of diazonium salts, that is the preparations of many organic compounds by using diazonium salts, and the one and only the reactions of diazonium salt that we have in our syllabus is a coupling reactions. We will just look at the questions regarding these coupling reactions at a later stage. Let us move to the questions. The first question is, among the following isomeric C4H11N amines, one having the lowest boiling point is. The question is the lowest boiling point of which isomeric amine among these 4 options they are asking. The option A and the option A is a primary amine. As I discussed before, a primary amine has got 2 hydrogen, which can show a greater hydrogen bond, intermolecular hydrogen bond, which makes that to have a very high boiling point. That's why option A is wrong. Option B and C are secondary amines, which has got 1 hydrogen each, which can also show a high intermolecular hydrogen bond, which makes to have a higher boiling point compared to the tertiary amine, which doesn't have hydrogen here. Due to the absence of hydrogen in tertiary amines, and also due to the symmetrical nature, it's not symmetrical, but due to the presence of alkyl groups, it may acquire a spherical structure, which may induce a less van der Waals force of attractions between the tertiary amines, and also due to the absence of hydrogen, it may have a less boiling point. Therefore, according to the concept, we can have boiling point is directly proportional to intermolecular hydrogen bonding. That is, a primary amines will have higher boiling point compared to secondary amines, and then secondary amines will have higher boiling point compared to tertiary amines. Therefore, the correct answer is option D. The second question is, treatment of ammonia with excess of ethyl iodide will yield. Treatment of ammonia with excess of ethyl iodide means the reaction is ammonolysis reaction. Ammonolysis reaction is a reaction of an alkyl halide with ammonia in order to get at primary, secondary, tertiary and quaternary amines. For example, if I take ammonia and ethyl iodide C2H5I, due to this lone pair, it will be treated as a nucleophile and it will attack this carbon, and I will go off, HI will go off, and you will get a primary amine like C2H5NH2. The lone pair of electrons present on nitrogen atom is retained now. Again, with the excess of ethyl iodide C2H5I, again this primary amine interacts with this C2H5I, and I will go off, and you will get a secondary amine like C2H5N, C2H5H. Still the lone pair electrons on nitrogen atom persist. One more reaction you can have, C2H5I, I will go, and you will get C2H5 thrice N, you will get a triethyl amine. Still lone pair of electrons on nitrogen atom is there. You can have one more reaction, it can attack this, and I will go, HI will go off, and you will get finally a tetraethyl ammonium salt. That is what tetraethyl ammonium iodide. Therefore, the option D is the correct answer. Next, which of the following is the strongest base in aqueous solution? Okay, look at the structures of each options. This is a methylamine, this is trimethylamine, this is aniline, and this is dimethylamine. The basicity of amines depending on the availability of lone pair of electrons present on nitrogen atom. In this aniline structure, the lone pair electrons of nitrogen are delocalized over the conjugated system. Thereby, the availability of lone pair of electrons for the protonation is difficult here. Therefore, it is a weak base. But in these 3 options, methylamine, trimethylamine and dimethylamine, we are having inductive groups like methyl groups, which are used to induce more electron density around the nitrogen atom. Therefore, we can think it like more is the number of inductive groups, positive inductive groups, more will be the basic nature. But here they are asking for the basicity in aqueous solution. Aqueous solution means the amines are in contact with water. Here there will be an hydrogen bond present between amines and water as well. As the number of alkyl group increases around the nitrogen atom, steric factor dominates over the inductive factor. Steric factor dominates over inductive factor, which makes this tertiary amine less basic. Therefore, we can think like the order of basicity will be secondary, primary and tertiary in aqueous solution. If it is in vapor phase, the molecules will be far apart. There is no question of steric factor. Then the order of basicity will be tertiary is greater than secondary is greater than primary. Therefore, to this question, the option D is the right answer. We have got we have got two alkyl groups in dimethylamine, which are positive inductive group, which increases the electron density around nitrogen atom, thereby the basic nature of amines also increases. Next, we will move on to the next question. In the chemical reaction, CH3CH2NH2 plus CHCl3 plus 3KOH give rise to A, B plus 3H2O. The compounds A and B are respectively. Look at the equation. This is the primary amine with a chloroform and an alkali, potassium hydroxide we have used. We can remember the reaction carbyl amine reaction. A carbyl amine reaction is a specific reaction for primary amines, which on treatment with chloroform and alkali, it gives an isocyanide of that particular amines, which gives an offensive smell, which is also a characteristic equation used to predict the nature of an amines like primary amines. Because the secondary amines and tertiary amines won't react won't react in this case. Therefore, the options A, C2H5NC, an isocyanide is obtained, and the side product is KCl. In option B also we are having a isocyanide and KCl. Since it is a carbyl amine reaction, the name itself explains carbyl amine is an isocyanide. Therefore, the product must be an isocyanide. Therefore, option B we are having a nitrile, and option C we are having an amide, a propanamide. Therefore, option B and C are wrong. In option A and D we are having isocyanide, but the side products are K2CO3 and KCl. Obviously, in carbyl amine reactions we need to expect a side product KCl. That is why option A is right. Next question. Which of the following forms butter yellow with benzene diazonium chloride? This is a reaction of benzene diazonium chloride with an aromatic system which carries an electron donating groups like alcohol in OH in phenol, OH in naphthol and phenol, and NH2 and dimethylaniline. Okay, look at the equations. When benzene diazonium chloride is reacting with alpha naphthol. Okay, sorry, this is beta naphthol actually. Okay, when benzene diazonium chloride reacts with beta naphthol, you will get a substituted product. This reaction is an electrophilic substitution reaction. Electrophilic substitution reaction in which an electrophile H plus will be replaced by an electrophile benzene diazonium chloride. You will get this product, which is orange red in color. When benzene diazonium chloride reacts with a dimethyl aniline, you will get a butter yellow. When it reacts with phenol, you will get an yellow orange solution. When it reacts with aniline, you will get an yellow solid. In all these three cases, the para hydrogen of these substituents have been replaced by this benzene diazonium chloride. But in case of beta naphthol, the alpha hydrogen of this beta naphthol is been replaced by benzene diazonium chloride. The question is, which of the following forms butter yellow? The correct answer is option B. Next question, a butane nitrile which on treatment with water in the presence of base OH minus, and he has given incomplete hydrolysis, that is partial hydrolysis. You will get some compound which on treatment with bromine and KOH, you will get a final product, and they are asking for the product. It seems option A is propylamine, option B is ethylamine, option C is propylamine itself, option D is butane nitrile. Okay, option A and C are same, it seems. Okay, just we'll look at the reaction first. We are having butane nitrile CH3 CH2 CH2 Cn, which on partial hydrolysis, you should remember this, upon partial hydrolysis the functional group nitrile will be converted into an amide group CH2 CH2 CO NH2. If it is a complete hydrolysis, then it would have converted to a carboxylic acid. Since they have given it's an incomplete hydrolysis, because of this partial hydrolysis, Cn will be converted into an amide. Next, this amide, when on treatment with bromine in the presence of KOH, this reaction is called as Hofmann's bromamide reaction. Hofmann's bromide reaction is nothing but a decarbonylation reaction. Decarbonylation reaction means a removal of CO group, carbon monoxide, from this reactant. Directly we can write the product by eliminating this CO. You will be having CH3 CH2 CH2 NS2. You will have a primary amine. So option A is the right answer. Okay, next question. Primary amine with Hinsberg reagent forms option A N-alkyl sulfonamide soluble in KOH solution, option B N-alkyl sulfonamide insoluble in KOH solution, option C N, N dialkyl sulfonamide soluble in KOH solution, option D N, N dialkyl sulfonamide insoluble in KOH solution. Now we will have a solution. This is what we called as Hinsberg reagent. A benzene sulfonyl chloride which on treatment with primary amine, it will undergo condensation reaction by the removal of HCl molecule. You will get an alkyl substituted benzene sulfonamide. This benzene sulfonamide has an acidic hydrogen. Therefore, when you treat this alkyl substituted sulfonamide with sodium hydroxide, being a base, sodium hydroxide will abstract this proton and you will get a soluble salt which can easily dissolve in a solution. When this benzene sulfonyl chloride reacts with a secondary amine, the condensation of HCl leads to the formation of dialkyl substituted NN dialkyl sulfonamide, which is not soluble in sodium hydroxide because we do not have acidic hydrogen here. Therefore, there is no reaction between a disubstituted benzene sulfonamide with NaOH or potassium hydroxide, any base you can take. Since tertiary amines do not carry hydrogen, Hinsberg reagent does not react with this tertiary amine. This is what the basic used to isolate a primary amine from secondary amines and tertiary amine. Therefore, when primary amine with Hinsberg reagent, when it reacts, it will form an N-alkyl sulfonamide which is soluble in potassium sodium hydroxide. Therefore, the option A is the right answer. Question number 8. The reagent which could distinguish aniline from cyclohexylamine is. Look at the solution. aniline is an aromatic primary amine and cyclohexyl amine is a cyclic aliphatic primary amine. Then by using now we will look at the option. Option A is NaNO2 and HCl at 5 degrees centigrade, then 2-naphthol, that is nothing but beta-naphthol. See, this is the characteristic reaction of a primary aromatic amine. Among these two, aniline is a primary aromatic amine when it is reacting with sodium nitrite in the presence of dilute HCl at 0 to 5 degrees centigrade, you may get benzene diazonium chloride, a diazotization reaction. Then when it is treated with 2-naphthol, that is beta-naphthol, coupling reaction takes place. You will end up with a product, aza product, which is an orange red dye. Since you are getting a colored precipitate with aniline, you can easily distinguish an aniline from a cyclohexyl amine, which is a primary aliphatic amine. When it is reacts with sodium nitrate, you won't get diazonium chloride, instead you will get a cyclohexyl alcohol, that is cyclohexanol you will get. Thereby we can easily distinguish this aniline from cyclohexyl amine by using sodium nitrate HCl and then followed by the treatment of 2-naphthol. Other options like B, CH3COOH, NH2OH and H2O. Ammonium, this hydroxylamine is a reagent used to differentiate a carbonyl compounds from other organic compounds. Therefore, the option B is wrong. And cold dilute NaHCO3 and cold dilute HCl are mild acids which can easily dissolve both aniline and cyclohexylamine. Therefore, option C and D is also wrong. We can easily distinguish these two compounds by using option A, the reagent which is present at option A. Therefore, answer is A. Next question. Bromination of aniline gives 2,4,6-tribromoaniline, whereas the nitration of aniline with mixed acids gives metanitroaniline. In case of nitration, the meta derivative is formed because option A, in the presence of strong acids, the amino group is protonated to NH3 plus, that is anilinium ion, which is a meta orienting group. Option B, metanitroaniline is thermodynamically more stable than the ortho and para isomers. Option C, nitro group cannot enter ortho and para positions due to steric factor. Option D, the mechanism for bromination and nitration are different. We will have this equation first. Bromination of aniline gives 2,4,6-tribromoaniline. When aniline reacts with bromine water, your product will be 2,4,6-tribromoaniline. Since it is a highly activating group NH2, it will activate all the ortho and para positions of benzene. That is why all the ortho and para hydrogens of this aniline will be replaced by Br. Being ortho para director, the incoming electrophile should reach at these ortho and para positions. While in case of nitration, the reagents that were used is concentrated sulfuric acid and concentrated nitric acid. Being a stronger acid, sulfuric acid donate a proton towards this aniline, which is a Lewis base. During the course of the reaction, this happens. H2SO4 being a stronger acid compared to HNO3, it will donate a proton towards this Lewis base and you may get a product NH3 plus HSO4 minus. This is an anilinium ion which is a meta director actually. Meta director means it will influence the incoming electrophile towards the meta positions only. Therefore, upon nitration, you may get a meta product as a major product. Nitration is an electrophilic substitution reaction in which the hydrogens, ortho or para or meta hydrogens of these benzene will be replaced by NO2 group and electrophile NO2 plus. Therefore, you can expect the substitution over ortho, para and meta positions, but this substituent will influence the electrophilic substitution reaction. NH3 plus being a meta director, your product will be para-nitroaniline and meta-nitroaniline are the major products of this anilinium ion. You may expect 0.02% of ortho-nitroaniline as well. Therefore, the option A is the correct answer. In the presence of strong acids, the amino group is protonated to NH3 plus anilinium ion, which is a meta-orienting group. Therefore, answer A is the right answer. Option A is the right answer. Sorry. Next question. An optically inactive amine C4H11N on the treatment with HNO2 gives an alcohol B. The compound B on heating with concentrated sulfuric acid at 453 Kelvin gives an alkene C. C on treatment with HBr gives an optical active compound D. Having molecular formula C4H9Br, identify A. Okay. First we will look at the molecular formula C4H11N. Since it does not have any oxygen or something like that, you can treat this as a amines. If you are having oxygen means you may expect it may be a nitro compound, and also they are giving C4H11N on treatment with HNO2 gives an alcohol. This sentence is enough to describe the nature of the amines, which is a primary aliphatic amine. Because only primary aliphatic amine on treatment with HNO2 gives an alcohol. If it is a primary aromatic amine, you may get a benzene diazonium chloride. That is why in look at the options C and D, both are secondary amines. Therefore, you can easily take out these two options. Option A and B are primary amines. Therefore, you can move on to the question next. The compound B on heating with concentrated sulfuric acid at 453 Kelvin gives an alkene C. Okay. When I will just take an option B, CH3, CH2, 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 NH2, which on treatment with HNO2, as I said, it will give an alcohol CH3, CH2, CH2, CH2OH, which on treatment with concentrated sulfuric acid at 453 Kelvin, concentrated sulfuric acid being a dehydrating agent, it will remove water molecule from this alcohol, and this is also a beta elimination reaction. You will get a compound like CH3, CH2, CH2 double bond, sorry, CH double bond CH2. This is alkene C you can get. If you take this amine CH3, CH2, CH, NH2, CH3 with HNO2, you will get a secondary alcohol CH2, CHOH, CH3. On treatment with concentrated sulfuric acid, you may get a mixture of alkenes like CH3, CH2, CH double bond CH2 and CH3, CH double bond CH, CH3. That is why I did not prefer this option. They are telling that the compound B on heating with concentrated sulfuric acid at 453 Kelvin gives an alkene C they have given. That is why you may expect only one product, that is CH3 CH2 CH double bond CH2 by this option. Next, on treatment with HBr and alkene C, it may give, this is an addition reaction. In accordance with Markovnikov rule, we can add this Br minus to the carbon containing less number of hydrogen. You may get CH3 CH2 CBr H CH3. See, the C on treatment with HBr gives an optically active compound D. This is what they have given. Yes, it is optically active because you are having a chiral carbon here. The compound which has got chiral carbon will be optically active in nature. That is why option B is the right answer. We will move on to the next question. Match the entire of column 1 with appropriate entries of column 2 and choose the correct option out of the 4 options given at the end. Column 1, aniline, B, N-methyl aniline, N-dimethyl aniline and benzylamine. In column 2 they have given can be made by Gabriel thalamide reaction, undergoes electrophilic substitution reaction with HNO2, forms yellow oily product with HNO2 and gives azo dye test. We will look at this first, a Gabriel thalamide reaction. As I said, Gabriel thalamide reaction is used to prepare a primary aliphatic amines only. Gabriel method is used to prepare primary aliphatic amines only. You can look at the option. Aniline is aromatic in nature. The structure of aniline is this. N-methyl aniline is this. N-diethyl aniline, C2H5 and benzylamine is a benzene with CH2NH2. Out of these 4 options, the last option, the D, benzylamine, is the only primary amine which we have, which can be prepared by Gabriel thalamide reaction. Therefore, P will be correlated with an option D, which is at only option A. No other options is having a match of D and P. See, D and R, D and Q and D and S. Just by looking at this, we can easily sort it out that answer for this question is option A. Doesn't matter, we will look at the other option as well. N-methyl aniline, okay. Another concept at R is forms yellow oily product with HNO2. Yellow oily product means it must be a nitrosoamines. HNO2, if it is treating with an amine and it is giving an yellow oily product, means it must be a nitrosoamines, and it is a characteristic reaction of a secondary amines. Primary amines with the treatment of HNO2, if it is aliphatic, it will give alcohol. If it is aromatic, you will get a diazonium chloride. If it is a secondary amine, both aliphatic and aromatic amines will produce a nitrosoamines, and which has got a characteristic color. It is an oily product, yellow oily product. That's why R can be correlated with a secondary amine. A secondary amine out of these 4 options is N-methyl aniline. Therefore, you can correlate B with R, that is there, and C with Q. N-diethyl aniline undergoes electrophilic substitution reaction with HNO2, a coupling reaction, and N-diethyl aniline C with Q and D with P, and aniline A with S. Already we have gone through this equation reaction. Aniline being an aromatic amine with the treatment of HNO2 and followed by the treatment of aromatic system bearing OH, NH2 and other electron donating groups, it will give an azo dye. Therefore, the option A is the correct answer. Next, we will move on to the next chapter, biomolecules. Biomolecules are agent molecules which are used for the development of growth and metabolism activity present in our body. I have just given a concept map of these biomolecules, which may consist of carbohydrates, proteins, nucleic acids, vitamins and hormones. In this carbohydrates parts, you will be studying the classification of carbohydrates and the structural information of carbohydrates. Carbohydrates can be classified into monosaccharide, oligosaccharide and polysaccharide based on the hydrolysis of these sugar units. Monosaccharide does not undergo hydrolysis, whereas oligosaccharides undergoes hydrolysis to produce 2 to 10 monosaccharide units. Polysaccharide, it's a polymer of carbohydrate which may induce more than 20 monosaccharide units. And you need to study the structural details of all these carbohydrates, like a monosaccharide like glucose, fructose, mannose, galactose, and disaccharide like sucrose, lactose, maltose, and polysaccharides like starch, cellulose, glycogen, etc. The structural details means you need to study the Fisher's projection as well as the Haworth projection of these carbohydrates. Next part is proteins. Proteins are polymers of amino acids, and these amino acids are inorganic compounds which contain two functional groups like carboxylic group and amino group. These are building blocks of proteins. And next we will be looking at the structure of a protein. Structure of a protein will be classified into 4 types: a primary structure, a secondary structure, quaternary structure, tertiary structure and quaternary structure. The last part of protein is denaturation. Denaturation is a process of losing its biological activity. Losing a biological activity of a protein by the application of heat or pH, the change in pH. Next part is nucleic acids. You can consider these nucleic acids as a polymer of a nucleotide. A nucleotide may consist of 3 parts: a pentose sugar, a nitrogenous base and a phosphate group. A pentose sugar may be a ribose sugar or deoxyribose sugar. If it is ribose sugar, it will be present in RNA. If it is deoxyribose sugar, it will be present in DNA. The nitrogenous bases are purines and pyrimidines. Purines are a bicyclic compounds which are adenine and guanine, and pyrimidines are a monocyclic compounds which are uracil, cysteine and thymine. And a phosphate group which will be linked to this pentose sugar, giving this nucleotide. Okay, and then the polymerization of this nucleotide may tends to the formation of DNA and RNA which are present in chromosomes. The next part is vitamins. Vitamins are inorganic molecules which we regularly take through a diet and which are responsible for growth and metabolism. We need to classify these vitamins based on their solubility. We will be looking at these vitamins A, B, C, D, E and K. The vitamin B and C are water soluble vitamins. The rest of the vitamins are fat soluble vitamins, and their functions we need to see. The last part is hormones, which are the chemical messengers or the chemical substances which are produced in the ductless glands, and their the classification based on the function group present in an hormone and their role we have to see. Next we will go with the questions of carbohydrates. Question number 12. In fructose and glucose, the possible optical isomers, optical isomerism, that means the tendency of that particular substance to rotate a plane polarized light to either left or right. Then look at the solution. The fructose is a ketohexose which is having a ketone group. A glucose is an aldohexose which is having an aldehyde group with 6 carbon atoms. Optical isomerism, the conditions for optical isomerism is, the first condition is molecule should have a chiral carbon, and the next condition is it should be free from all types of symmetry. Then only the molecule is said to be optically active. In fructose, you are having 3 chiral carbons, and in glucose you are having 4 chiral carbons. Therefore, the first condition is satisfied, and also it is not having any type of symmetry. Therefore, these fructose and glucose are optically active, but they are asking for the possible optical isomers for fructose and glucose. You can have this formula 2 to the power n, where n represents number of chiral centers present in a molecule. In fructose we have 3 chiral center, therefore the formula 2 to the power of n is 2 cube, that is you can have 8 isomers. 2 to the power of n represents the number of optical isomers possible number of optical isomers for these molecules. For glucose you are having n is equal to 4, that is 2 to the power of n, that is 2 to the power of 4, that is 16 isomers you can have. Therefore the option B, fructose is having 8 optical isomers and glucose is having 6 optical isomers. The option B is the correct answer. Which of the following carbohydrates is used in the silvering of mirrors? Option A sucrose, option B cellulose, option C starch, option D glucose. Silvering of a mirror is, it's just a process which converts a plain glass sheet into a mirror. For this purpose we are going to use an ammonical silver nitrate, which is nothing but a Tollens reagent. Being a mild oxidizing agent, Tollens reagent, it may react with certain aldehydes to produce a silver plane on the sheet of a glass. Then we will be looking at the structure of sucrose, cellulose, starch and glucose. This is the structure of sucrose. In sucrose we are having a linkage of a glycosidic linkage of 1 and 2, therefore we don't have free aldehyde group to undergo oxidation. A simple starch and a cellulose, these are also a polymers which doesn't carry free aldehyde group, but glucose has got a free aldehyde group to undergo oxidation. If you treat this glucose with an ammonical silver nitrate, AgNH3 twice plus with this aldehyde group, you may end up with the formation of silver and the COHO will get converted to COONA. You will get the acid part of this aldehyde, CO minus Na. Therefore, the presence of aldehyde group is necessary for silvering of mirrors. Option A, B and C doesn't have a free aldehyde group, whereas option D, glucose, is having a free aldehyde group to undergo oxidation in the presence of a mild oxidizing agent, a Tollens reagent. Thereby you are getting a surface of silver on the plane of the glass sheet. That's why option D is the right answer. Glucose is used in silvering of mirrors. Next question. Select the incorrect statement. Option A, glucose and galactose are epimers at C4. Option B, glucose and galactose are epimers at C2. Option C, glucose and mannose are epimers at C2. D, all of this. We will have the structures of glucose, galactose and mannose first. This is the structure of mannose, open chain structure, and this is the structure of glucose and this is the structure of galactose. All these are isomers having a same molecular formula C6H12O6. The only difference is mannose, for mannose and glucose there is a configurational change at carbon number 2. Okay, please have a correction. This is galactose and this is mannose. Sorry. Okay, this is the structure of mannose. It has been interchanged. This is the structure of galactose. Glucose and galactose are isomers having same molecular formula, but the only difference is the configurational change at carbon number 4. 1, 2, 3, 4. Look at this. 1, 2, 3, 4. The entire structure is same except at carbon number 4 the H is present at the right side and here H is present at the left side. Therefore, glucose and galactose are epimers. By definition itself, epimers are isomers having a same molecular formula, but the difference is configurational difference other than carbon 1. Epimers are isomers which are having a configurational difference other than carbon 1. If you are having a configurational difference at carbon number 1, it will be an anomer. Therefore, both galactose and glucose are epimers and glucose and mannose are epimers. Now look at the option. Glucose and they are asking for an incorrect statement. Glucose and galactose are epimers at C4. Yes, it is. At C4 there is a configuration change. Therefore, these two are epimers. Option A is a correct statement. Next, option B. Glucose and galactose are epimers at C2. No, these are not epimers at C2. They are epimers at C4. Therefore, option B is wrong statement. Option C. Glucose and mannose are epimers at C2. Yes, it is. Glucose and mannose, they are epimers at C2 configuration. See, you are having a configuration difference at C2. OH is at left side here and OH is at right side here. This is also a correct statement. If B is a wrong statement, D is not, then the option D is not the right answer because B is wrong. Therefore, the incorrect statement will be option B. Which is not a true statement? Option A. Alpha carbon of alpha amino acid is asymmetric except glycine. Option B. All naturally occurring proteins are found in L form. Option C. Human body can synthesize all proteins they need. Option D. At pH is equal to 7, both amino and carboxylic group exist in the ionized form. Let us have the solution. We'll have this option first. Option A. Alpha carbon of alpha amino acid is asymmetric except glycine. Yes, it is a correct statement. This is the structure of glycine. It is the only amino acid which is achiral in nature. Achiral means carbon is not having 4 different substituent. Therefore, it is not optically active. Therefore, it is not optically active. All other 19 naturally occurring amino acids will be optically active except this glycine. Therefore, this is a true statement. Next, option B. All naturally occurring proteins are found in L form. Yes, it is. This is also correct statement by definition itself. All naturally occurring amino acids are also found in L form. Option C. Human body can synthesize all proteins they need. This is also a correct statement. Human body can synthesize all the proteins it requires. Option D. At pH 7, both amino and carboxylic group exist in the ionized form. See, ionization of different amino acids takes place at a specific pH value, which is what we called as isoelectric point. It is not necessary for an amino acid to have the same pH value 7 to exist in a Zwitterion form. Based on this isoelectric point, different amino acids are having different pH values. This isoelectric point is that particular point where exactly the cation part of amino acid neither migrate towards the cathode and the anionic part of the amino acid nor migrate towards anode. Therefore, it is not necessary for all amino acids to be present in its ionized form at pH 7 only. Therefore, this is not a true statement. Therefore, option D is the right answer. Question 16. Fructose gives the silver mirror test because already we have gone through this question. Silver mirror test is applicable for those type of carbohydrates which can carry an aldehyde group. Let us have a structure of fructose. Fructose is a ketohexose which contains a ketone group. Actually, ketone group containing organic molecule doesn't react with Tollin's reagent. Therefore, fructose directly it won't give a positive test for Tollin's reagent. That means you won't get a silver mirror for this fructose. Option A they have given like fructose contains an aldehyde group. No, it is not. It is having a ketone group. Option B contains a ketone group. Yes, it is, but ketone group containing organic compound doesn't react with Tollens reagent to produce a silver mirror. Option C is it undergoes a rearrangement under the alkaline conditions of the reagent to form a mixture of glucose and mannose. Yes, it is in the presence of an alkali, because Tollens reagent is having sodium hydroxide as well. Being a base, on alkaline rearrangement, fructose may give mannose and fructose, which carries an aldehyde group, which may be responsible for the production of silver mirror. Therefore, option C is the right answer. On rearrangement, fructose with sodium hydroxide, it produces mannose and glucose, which carries aldehyde group, which is responsible for the formation of silver mirror on the sheet of glass. Therefore, option C is the right answer. 17. In an amino acid, the carboxyl group ionizes at pK1 dissociation constant of that particular acid, that is equal to 2.34, and an ammonium ion at pKa2 dissociation constant for that ammonium ion is 9.60. The isoelectric point of the amino acid is at pH. Option A 5.97, option B 2.34, option C 9.60, option D 6.97. You can calculate the isoelectric point of an amino acid by the formula pH is equal to pKa1 plus pKa2 divided by 2. Substitute these values, pKa1 of 2.34 and pKa2 9.60. You will be having an answer of 5.97, which is at the option A. Therefore, the correct answer is option A. Okay, next question. Bioretest is not given by. Bioretest is a simple test to predict the nature of an amide bond present in a molecule, or else to check the presence of CONH bond in an organic molecule. Since proteins are made up of amino acids, which are obtained by condensation reactions of amino acids via peptide linkages, protein must have CONH bond. Polypeptides means again polypeptides are also obtained by condensation reactions of amino acids. Therefore, the peptide bond itself is CONH. Carbohydrates, these are polyhydroxy aldehydes and ketones, which doesn't carry this amide bond. In carbohydrates, we can't see this amide bond. Urea, NH2C double bond O NH2, we can have this CONH bond. And biurate reagent is an alkaline copper sulfate solution, that is Cu2 plus with OH minus. When it reacts with organic molecules bearing a peptide bond, you will get a purple color, which indicates the presence of CONH bond in an organic molecule. Therefore, the question is Bioretest is not given by. Since carbohydrates doesn't have this CONH bond, Bioretest is not answerable by carbohydrates. Therefore, option B is the right answer. Next question. Which of the following is a non-steroidal hormone? Option A estradiol, option B prostaglandin, option C estrone, option D progesterone. See, these are the structures of the options given above. This is a structure of estradiol, this is progesterone, this is estrone, this is prostaglandin. Steroidal hormones are a class of hormones which has a specific basic unit called this 4-membered ring structure. If an organic molecule possesses this 4-membered ring structure, 4 fused ring structures, then it will be considered as a steroidal hormone. In all these 3 options, estradiol and estrone, as well as in progesterone, we are having this basic skeleton, a 4 fused rings, that is a 3 6-membered rings and 1 5-membered ring. These 3 hormones can be considered as steroidal hormones. In prostaglandin, we don't observe this basic skeleton which is necessary for steroidal hormone. Therefore, prostaglandin can be considered as a non-steroidal hormone. Option B. Then option B is the right answer. What form of glutamic acid would you expect to predominate in strongly base solution? See, glutamic acid is having this structure CH2, CH2, COOH. In strongly base solution means a pH will be around greater than 7. Base solution means it can easily dissociate this COOH minus to COOH to COO minus. In basic medium, this base will abstract both the acidic protons of this, and your glutamic acid may be present as COO minus, CH2, CH2, COO minus. It is there in option B. If it is acidic medium, it may give H plus ion towards the basic part of amino acid, that is NH2 plus. They are asking for form of glutamic acid in strongly basic solution, that is why it will dissociate this COH to CO minus and CO minus, that is there in option B. Therefore, option B is the right answer. Adenosine is an example of a option A nucleotide, option B nucleoside, option C purine base, option D pyrimidine base. See, this is the structure of adenosine. Adenosine is a combination of a nitrogenous base adenine and a pentose sugar, collectively called as a nucleoside. If this OH is associated with some phosphate group, then it will be considered as a nucleotide. They are asking for only adenosine. This is a structure of adenosine containing components of adenine and pentose sugar. Therefore, adenosine can be considered as a nucleoside. Purine bases means only the nitrogenous bases like adenine and guanine can be considered as purine bases, adenine and guanine. Pyrimidine bases are cytosine, thymine and uracil. Therefore, option B is the right answer. 22. The catalyst used in the manufacture of polythene by Ziegler method is. A Ziegler method is a preparation of polythene by a monomer ethene, CH2 double bond CH2 at 7 to 8 atmospheric pressure, 300 to 400 Kelvin temperature, in the presence of a catalyst triethyl aluminium and titanium tetrachloride, which will be considered as a Ziegler Natta catalyst. This ethene molecule undergoes polymerization to produce a polythene, which is also considered as HDPE, high density polyethylene. Therefore, the catalyst used during the preparation of HDPE is triethyl aluminium and titanium tetrachloride, which is there at option B. Therefore, for this question, the option B is the right answer. The other options like titanium tetrachloride and triphenyl aluminium, titanium dioxide and titanium isoperoxide we have not used for the preparation of polythene. Therefore, option B is the right answer. 23. Bakelite is made from phenol and formaldehyde. The initial reaction between the two compounds is an example of Bakelite is a polymer, a three-dimensional polymer which is obtained by monomers called phenol and formaldehyde. The initial reaction between the two compounds is this. You are having phenol with formaldehyde, which is having an electrophilic site carbon and a nucleophilic site. In the end, this oxygen may abstract this proton, and aromatic property of benzene, that means phenol, retains, and you will get this product. This is the initial reaction between the two compounds phenol and formaldehyde, which is an electrophilic substitution reaction actually. See, the electrophile carbon has been replaced by this electrophile H+. Therefore, the initial reaction between phenol and formaldehyde is an aromatic electrophilic substitution reaction. This is not a free radical reaction or else the aldol reaction. Aldol reaction, the condition is the molecule must have alpha hydrogen. This aldehyde, formaldehyde doesn't have alpha hydrogen, therefore aldol reaction is not possible. And also you can see there is an exchange of electrophiles between the phenol and formaldehyde, therefore it is not a nucleophilic substitution reaction as well. Since you don't have any radical initiators or like sunlight, the reaction doesn't proceed with a free radical mechanism as well. Therefore option A is the right answer. 24. Chloroprene is obtained by addition of HCl2. First we will look at the structure of chloroprene. This is the structure of chloroprene. 2-chloro-1,3 butadiene, which is a monomer of a neoprene. Which is also considered as artificial rubber. See, now we have to prepare this chloroprene by the addition of HCl2. Which of these options they are asking? Look at the molecule chloroprene. It is having 4 carbon atoms. If you add HCl to acetylene, you may get a vinyl chloride which is having only 2 carbon atoms, that is acetylene is CH triple bond CH. When you add HCl to this, according to Markovnikov rule, here it is not necessary because it is a symmetrical alkyne, you may get CH2 double bond CHCl, you will get a vinyl chloride which is not chloroprene, that is why option A is wrong. If you have vinyl acetylene, vinyl group is CH2 double bond CH, acetylene is C triple bond CH, this is vinyl acetylene. When you treat this with HCl, according to Markovnikov rule, the negative part should goes to carbon containing less number of hydrogen. Here across the triple bond, you may get CH2 double bond CH, CCl double bond CH2, which is a chloroprene. Therefore, option B is the right answer. Divinyl acetylene is CH2 double bond CH, C triple bond C, CH double bond CH2. You are having 6 carbon atoms. By using this, you can't prepare chloroprene, which is pairing only 4 carbon atoms. And phenyl acetylene, we don't have phenyl group in chloroprene. That's why this reagent is also wrong. Therefore, option B is the right answer. When you add HCl to vinyl acetylene, you will get a chloroprene, which is a monomer of an artificial rubber neoprene. Therefore, option B is the right answer. A polymer which is used as a suture, that is for stitching of wounds after operation, is A. PHBV, poly beta hydroxy co beta hydroxy valerate, poly beta hydroxy butyrate co beta hydroxy valerate. It is a biodegradable polymer. Nylon 26, it is also a biodegradable polymer. Dextran, a dextran is a polymer of many glucose units, it is also biodegradable. Dacron, in other sense it is also called as pteryline, which is obtained by terephthalic acid and glycol. Dextran is a complex branched glucan, which is a polysaccharide made up of many glucose units, which is used for post-operative stitches. Therefore, option C, dextran, is right answer, which is used as a suture. 26. In the isoprene polymer, all the isoprene have, in the isoprene polymer means it must be a natural rubber, and a polymer which is made up of isoprene units, a natural rubber. All the isoprene have option A trans 1,4 configuration, option B cis 1,4 configuration, C both cis and trans 1,4 configuration, D none of this. Look at the structure of a natural rubber. Here you know what is cis and trans means. Cis means the substituents will be present at the same side, and trans means the substituents present at the opposite side. Here you can see the substituents with large molecular mass will be present at the same side, AA, like this. Therefore, you can treat this natural rubber as a cis polymer of that isoprene unit. Therefore, option B is the right answer. Nowhere you are observing the trans configuration, that is why option B is the right answer. If it is a if it is having a trans configuration, then it may be considered as a gutta percha. A trans isomer of that monomer isoprene unit. 27. Non-stick cookware generally have a coating of polymer whose monomer is. A non-stick cookware generally have a coating of polymer whose monomer is. A polymer which is used in non-stick cookware will be Teflon, PTFE, that is polytetrafluoroethene. This is the structure of tetrafluoroethene, which on polymerization you may get Teflon, a fluorinated polymer which is used generally in non-stick cookware. Therefore, option D is the right answer. Option A, it is an ethene used in the preparation of LDPE and HDPE, that is polyethene preparation. This is a vinyl chloride used in the preparation of PVC, polyvinyl chloride. This is acrylonitrile. Acrylonitrile is used in the preparation of PAN, polyacrylonitrile. The commercial name for this PAN is Orlon. Therefore, option D is the right answer. A tetrafluoroethene which is used in the preparation of polytetrafluoroethene, that is Teflon, which will be used in non-stick cookware generally. Therefore, option D. 28. If 30% molecules have M is equal to 20,000 and 40% molecules have M is equal to 30,000, rest of them have M is equal to 60,000, calculate PDI. PDI means polydispersity index. Which is generally used to check the homogeneous nature of polymer or else heterogeneous nature of polymers in the other sense. If polydispersive index approaches the value of unity, if PDI is approximately equal to 1, it means the polymer is homogeneous in nature. Homogeneous in nature, that means all the polymer chain length will be having equal length. If it is more than 1, then it will be heterogeneous in nature. Heterogeneous means the polymer chain length will be differ from one another. Therefore, the idea is used to check whether the given polymer is homogeneous or heterogeneous in nature. You can have a formula to calculate polydispersity index is MW by MN, where MW is weight average molecular mass of a polymer, MN is number average molecular mass of a polymer. MW can be calculated as M1N1 plus M2N2 plus M3N3 divided by N1 plus N2 plus N3, and Mn can be calculated as M1 square N1 plus M2 square N2 plus M3 square N3 divided by M1 N1 plus M2 N2 plus M3 N3. On substitution, you will get the value of 36 into 10 power 3 for MW and 43.3 into 10 power 3 for Mn. If you take the ratio of these two, MW by Mn, you will get 1.20. That means PDI is greater than 1.20. That means polymer is homogeneous in nature. They are asked for just the calculation of PDI. That is option D is the right answer. 29. Novolac is a linear condensation product of phenol and formaldehyde, cross-linked condensation product of urea and formaldehyde. Option C, cross-linked condensation product of phenol and formaldehyde. Option D, linear condensation product of urea and formaldehyde. Look at the structure of bakelite here. This is the structure of bakelite, which is obtained by a monomer, a phenol and formaldehyde, which is having a three-dimensional network-like structure. That means a cross-linked, it is obtained by a cross-linked condensation reaction by phenol and formaldehyde. Therefore, Novolac is a linear condensation product of phenol and formaldehyde. If it is a cross-linked condensation, then it will be considered as bakelite. A linear polymer of this bakelite like this will be considered as a Novolac. The condensation of urea and formaldehyde will be end up with a resins like urea formaldehyde resin. Therefore, the option B and D are wrong. Option A, a linear condensation product of phenol and formaldehyde. Already have showed this reaction. When phenol reacts with formaldehyde, it will give an initial product like this, which on condensation reaction loss of water molecule will give this product. Which will be considered as Novolac. Many times they have asked in the examination, the Novolac is a linear polymer of phenol and formaldehyde. If that polymerization extends over a three-dimensional space, then it will be considered as a bakelite. Therefore, Novolac is a linear condensation product of phenol and formaldehyde. Option A is the right answer. The commercial name for polyacrylonitrile is, the last question I think I have discussed this. The commercial name for polyacrylonitrile is PAN, which is a polymer obtained by an addition reaction of an acrylonitrile CH2CNCH, CH2CHCN. On polymerization, you will get this CH2. This is what PAN is. The commercial name for this PAN is Orlon. Therefore, option B is the right answer. Dacron is a commercial name of pterilene, which is obtained by condensation reaction of terephthalic acid and glycol. 31. Which of the following statements is not true? Option A, Buna S is a copolymer of butadiene and styrene. The name of the polymer itself explaining. In Buna S, Bu stands for butadiene and Na stands for sodium and S stands for styrene. Therefore, BuNaS is a copolymer of butadiene and styrene. Butadiene, when it is added with styrene in the presence of sodium, you will get BuNaS. Therefore, this is the correct statement. Option B, natural rubber is a 1,4 polymer of isoprene. We have discussed this before. Natural rubber is a 1,4 polymer of isoprene. This is also a true statement. Option C, in vulcanization, the formation of sulfur bridges between different chain make rubber harder and stronger. This is also correct statement. Option D, natural rubber has the trans configuration at every double bond. This is not a correct statement. Natural rubber has a cis configuration at each and every double bond. Therefore, the option D is not a correct statement, but for this question they are asking for which of the following statement is not true. Therefore, option D is the right answer, which is not a correct statement. You can look at the structure of isoprene on the polymer of isoprene, CH3 and H, or else the alkyl chain with a higher molecular mass will be present at the same side. Therefore, they will be having a cis configuration. 32. Which of the compound inhibits the synthesis of chemical known as prostaglandins, which stimulate inflammation in the tissue and cause pain? Okay, option B, Valium, a class of benzodiazepines used to control anxiety and it is used to withdrawal alcoholism. Serotonin, a 5-hydroxytryptamine, is a monoamine neurotransmitter and it is popularly thought to be a contributor to feelings of well-being and happiness. A morphine, which is a nitrogenous compound, organic compound, which can be considered as alkaloid, which acts directly on the central nervous system. They are asking for the chemical which stimulates the inflammation in the tissue and causes pain. That means we are in need of analgesic. Analgesic is a class of medicine which is used to kill the pain produced in the body. Therefore, aspirin is a analgesic which is used to kill the pain which is developed by prostaglandins. Therefore, option A is the right answer. 33. Which of the following is not a chlorinated insecticide? Option A, DDT. This is the structure of DDT. You can see there are 5 chlorine atoms present in this molecule. Option B, methoxychlore. Methoxychlore is this. We can see 3 chlorine atoms over here. Parathion. We don't see any chlorine atoms over this. BHC, benzene hexachloride, it is also called as gamaxine, which is having 6 chlorine atom over a cyclohexane ring. Therefore, the non-chlorinated insecticide will be option C. 34. Which of the following is known as broad spectrum antibiotics? Antibiotics are class of medicines which are used to treat the disease which is caused by microorganisms without affecting the host cells. And also these antibiotics will be classified into 3 types: broad spectrum antibiotics, narrow spectrum antibiotics and limited spectrum antibiotics. The option A, we have streptomycin, which is a limited spectrum antibiotic used for tuberculosis. In the option D, we are having penicillin G, which is a narrow spectrum antibiotic effective only against various cocci and some gram-positive bacteria. Ampicillin, a semi-synthetic modification of penicillin G, which is also a narrow spectrum antibiotic. Whereas the option C, chloramphenicol, a broad spectrum antibiotic which is used to treat many diseases like typhoid, dysentery, acute fever, pneumonia and certain urinary infections. Broad spectrum antibiotics are a class of antibiotics which are used to treat many diseases. Therefore, option C is the right answer. The formulation of Dettol contains option A, chloroxylenol, option B, terpineol, option C, alcohol, all of these. This is the structure of chloroxylenol, a parachlorometaxylenols. and this is the structure of terpineol. The composition in Dettol will be 4.8% of chloroxylenol and 9.9% of terpineol, and the rest of the thing will be absolute alcohol. Therefore, option D is the right answer. In Dettol, we can see all these three components. Which of the following is not an artificial sweetener? Artificial sweetener, it's a chemical substance used to induce sweetness in the substances which do not add any calories to the body. Option A sucralose, option B allitame, option C saccharin, option D sucrose. As we know, sucrose is a natural sweetener. Therefore, we can treat this as a non-artificial sweetener. And also we can see this, an allitame, sucralose and saccharin, these are artificial sweetening agents. Allitame is 2000 times sweeter than sucrose, and sucralose is 600 times sweeter than sucrose, and saccharin is 550 times sweeter than sucrose. And these three compounds will not add any calories to the body, but it will induce sweetness to the substances. 37. Such detergent is formed when stearic acid reacts with polyethylene glycol. Option A anionic detergents, option B cationic detergents, option C non-ionic detergents, D all of this. See, we are having the three types of detergents over here. Look at this equation. We have stearic acid with polyethylene glycol, and it is end up with a product which is considered as a non-ionic detergent because we don't have any substituents or functional groups present in its ion form, whereas here in cetyl trimethyl ammonium bromide it is present in its ion form Br minus as well as the whole ammonium ion, and it can be considered as a cationic detergents. And here you may have O minus and SO3H. You have SO3 HSO3 minus and CH2 plus, the positive part and the negative part over here. Therefore, you can treat this as an anionic detergents, and you can treat the cetyl trimethyl ammonium bromide as a cationic detergents, and this detergent which is obtained by the condensation reaction of stearic acid and polyethylene glycol can be considered as a non-ionic detergent. Therefore, a detergent which is formed by stearic acid and polyethylene glycol will be considered as a non-ionic detergents which do not have any ion form. So, option C is the right answer. Which one of the following types of drugs reduces fever? Class of medicines which reduces fever can be considered as antipyretic. The option given below are analgesic. Analgesic is a class of medicines which is used to kill the pain. Antipyretic, this is the correct answer, which is used to reduce the fever. Antibiotic, we already discussed about this, it is used to kill or it is used to reduce the activity of the microorganisms without affecting the host cells. And tranquilizers are class of medicines used to reduce the stress. Therefore, option B is the right answer. An antipyretic is used to reduce the fever. 39. Aspirin is an acetylation product of, as we all know, aspirin is an acetyl salicylic acid which is obtained by the second chapter, phenols. We have discussed about the synthesis of aspirin. We are having salicylic acid when it is treated with any acetylated product like acetyl chloride or else acetic anhydride. In the presence of acetic acid, in the presence of pyridine, a mild base, acetylation reaction takes place and you will get this. An acetylated salicylic acid which can be considered as aspirin. The reactant used for the preparation of aspirin is a salicylic acid, that is the common name. It is also called as orthohydroxy benzoic acid. Therefore, option B is the right answer. Artificial sweetener which is stable under cold conditions only is option A saccharin, option B sucralose, option C aspartame, option D allitame. All these are artificial sweetening agents. Saccharin is chemically it is orthosulfobenzimide. Sucralose, it's a trichloro derivative of sucrose. Aspartame, it's a dipeptide derived from phenylalanine and aspartic acid. Allitame is a structural analog of aspartame as well. But aspartame being a dipeptide, at baking temperatures like 100 degrees centigrade, it will undergo decomposition. That's why we can't use this aspartame at baking temperatures. Therefore, we can use this aspartame in artificial sweetener under cold conditions only, just for soft drinks like that. Option C is the right answer. 41. Nitrobenzene on reaction with concentrated nitric acid and sulfuric acid forms which one of the following products? Option A 1,4-dinitrobenzene, option B 1,2,4-trinitrobenzene, option C 1,2-dinitrobenzene, option D 1,3-dinitrobenzene. We'll have this reaction. Nitrobenzene is this, which on treatment with concentrated HNO3 and concentrated H2SO4, a nitrating mixture. It is an electrophilic substitution reaction in which an electrophile H of this benzene will be replaced by NO2 plus, but we are having a substituent NO2. It influences the incoming electrophile towards a meta position because it is a meta director. Therefore, this is ortho, this is meta, and this is para with respect to the substituent. Thereby we can expect a meta substitution, and this H plus will be replaced by NO2, which is furnished by concentrated sulfuric acid and HNO3, and you will get 1,3 dinitrobenzene as a major product. Therefore, option D is the right answer. 42. Method by which aniline cannot be prepared is option A degradation of benzamide with bromine in alkaline solution. We are having benzamide, bromine in alkaline solution. This is Hoffman's bromide reaction. As we all know, Hoffman's bromide reaction is a decarbonylation reaction. Thereby, you can easily get your aniline. We can prepare aniline by this method. Next, reduction of nitrobenzene with hydrogen and palladium in ethanol. This is nitrobenzene. Hydrogen and palladium is a very good reducing agent. Being a reducing agent, it will remove off this oxygen and it will induce hydrogen towards this nitrogen, and you may get aniline as a major product. Therefore, even by this method you can prepare aniline. Potassium salt of phthalimide treated with chlorobenzene followed by hydrolysis with aqueous sodium hydroxide solution. This is a Gabriel phthalimide synthesis. Potassium salt of phthalimide is this. When it is treated with chlorobenzene, you can expect this type of product, but this reaction will not happen because chlorine is attached to sp2 hybridized carbon atom. Here in the first chapter itself, you have studied that haloarenes will not undergo nucleophilic substitution reaction. In order to form an aniline from this method, this potassium salt of phthalimide has to react with chlorobenzene and it has to eliminate this chlorine. Being a nucleophile, it cannot approach this sp2 hybridized carbon atom. Because of its positive resonance effect, chlorine will show a partial double bond character with this carbon. Thereby, it will not, the nucleophilic substitution reaction will not be entertained by this phthalimide. Therefore, the preparation of aniline from this method will be restricted. Hydrolysis of phenyl isocyanide with acid solution. Phenyl isocyanide is NC. Hydrolysis in the presence of acid may give you aniline. Therefore, in all these three methods, option A, option B and option D, you can prepare aniline, but with option C, which is a Gabriel phthalimide synthesis, we can't prepare an aromatic amines like aniline. Therefore, option C is the right answer. 43. The number of structural isomers possible for the molecular formula C3H9N is C3H9N. You can easily say it is an amine. The number of structural isomers possible for this type of amines will be, first let us have a parent chain like this, 3 carbon atoms with NH2. This is the normal one, it is a primary amine, normal propyl amine. I will just change the position of NH2 to the second carbon. You may have structure like this. It is an isopropyl amine having the same molecular formula, but the only difference is the position of NH2. These two are considered as positional isomers. And next, you may have only these two primary amines are possible for the above said molecular formula. You may have secondary amine like this, CH3, C2H5, and also you may have a tertiary amine like this, CH3, CH3, CH3. Totally we can have 4 isomers. Therefore, option D is the right answer. 44. An organic compound C3H9N, when treated with nitrous acid, gave an alcohol, and nitrogen gas was evolved. A, on warming with chloroform and caustic potash, gave C, which on reduction gave isopropyl methylamine. Predict the structure of A. I think we have discussed this type of question earlier. When an amine is treated with nitrous acid and it is giving an alcohol, means the amine must be a primary amine. Option C is a tertiary amine and option D is a secondary amine. Therefore, option C and D are wrong, because the first reaction itself it won't perform, that is the reaction with nitrous acid. We have suspect on A and B now. Next, we will move on with the option B. When you have a primary amine, that is isopropyl amine, when it is warmed with a chloroform CHCl3 and a caustic potash KOH, which is nothing but a carbyl amine reaction, you may expect isopropyl amine, isocyanide like this, with the elimination of KCl and water, which can be considered as C. When C, isopropyl isocyanide, which on reduction, you can use any reducing agent, I will use H2 and PT. On reduction, you may get this product. This is the isocyanate part which will get reduced by this hydrogen and platinum, and you will get this. This is an isopropyl methyl amine. Therefore, option B is the right answer. If you choose option A with carbyl amine reaction, you may have this product, normal propyl isocyanide, which on reduction you may get this product, which is propyl methyl amine, methyl propyl amine, which is not given here. Therefore, option B is the right answer. Which of the following statement about primary amine is false? Alkyl amines are stronger base than aryl amines. Alkyl amines react with nitrous acid to produce alcohols. Aryl amines react with nitrous acid to produce phenol. Alkyl amines are stronger base than ammonia. First we will look at the option A. Alkyl amines RNH2 are stronger base than aryl amine. Aryl amine is this. Because of its positive inductive effect, alkyl group will induce more electron density around nitrogen atom. Therefore, the nucleophilicity around nitrogen atom increases for the abstraction of proton. Therefore, the basic character of alkyl amines will be obviously greater than aromatic amine. In aromatic amine, due to the delocalization of this non-bonded pair of electrons towards the conjugated system, there is no chance of the availability of lone pair of electrons on nitrogen atom for protonation is difficult. Thereby, alkyl amines are stronger base than aryl amine. This is a correct statement. Move on to the option B. Alkyl amines react with nitrous acid to produce alcohols. We have discussed this earlier also. Primary alkyl amines generally react with nitrous acid to produce alcohol. This is also a correct statement. Option C. Aryl amines react with nitrous acid to produce phenol. Aryl amines like aniline, when it is treated with HNO2, nitrous acid, dilute HCl, you will get a diazonium ion, which is a diazotization reaction. When you boil this diazonium chloride with water, then only you will get phenol. Directly you won't get phenol. Therefore, option C is wrong. Direct interaction of nitrous acid with aryl amine won't produce phenol. You will get a diazonium chloride, benzene diazonium chloride. Option D. Alkyl amines are stronger base than ammonia. Yes, it is. Alkyl amines when compared to ammonia. In ammonia we don't have any inductive groups, positive inductive groups, but here in alkyl amines we are having positive inductive groups. Thereby, the always positive inductive group increases the basicity of amines. Option D is also correct. Option C is the false statement. Therefore, answer C is the correct. Okay. To this, I am concluding this session. Thank you one and all.